Hello everybody, this video is about Unit 1, Part 2, topic number 4. We will be talking about the annual motion of the Earth and what changes that has on our night sky. We're going to follow this by not only how the stars are changing their position in the sky, but also where the sun is and with respect to the celestial sphere, how it is carving out its path as it winds around the celestial sphere over the course of 1 year. I'm going to go ahead and bring up my slides and we'll go ahead and get started, and I'll end this with a stellarium demonstration of the annual motions. All right, so we are talking now about annual motions. In the diurnal motions part, we were talking about the sun's rotation. So it's spinning about its rotation axis and the changes that that would cause, like things rise in the east, set in the west. In this one, we are going to be talking about the Earth's orbital motion, its revolution around the sun. So over the course of 1 year, as the Earth orbits the sun, we want to know how that changes what we see at night in our night skies. And we would like to understand where the sun would be if we could turn the sky off. So where amongst the stars would the sun be? For this, we are not going to consider the rotation of Earth at all. So I'm going to, for all of the animations that I'm about to show you, the Earth is going to be frozen and you're going to be observing at midnight. So notice that this purple line right here is in the middle of the night. And we will again be looking down on the North Pole. So the Earth would be rotating this way. This would be towards the eastern horizon. This would be towards the western horizon. This will mark our meridian that's pointing towards zenith. So what we're going to do is I'm going to let the Earth rotate about the sun, or revolve around the sun as it completes its orbit. And let's just go ahead and use the meridian. Where this purple arrow is pointing will show us what stars would be on the meridian at midnight. So we will see how what stars are visible change over the course of 1 year. So there it goes, and you can see that clearly based on where the Earth is in its orbit, what time of year it is, what stars are going to be above your horizon, what stars are visible, are changing throughout the course of a year. Another way to think about this is there will be summer constellations and winter constellations, spring constellations and fall constellations. What stars you can go out and observe depend on what time of year it is, or what stars you can go outside at night and observe, depend on what time of year it is. I'll go ahead and play that animation one more time. Because one of the questions we might want to ask ourselves is, okay, if we're going to go out night after night from solar day to the next solar day, we're going to go out from one midnight to the next midnight and observe the stars, what kind of changes would we observe? If we're going to see essentially a different set of stars as the year progresses and then it comes back to where it started, so we'll have this annual progression of what constellations are up. What motions do we see on a night-to-night basis? So with this one, I'm actually going to put our label of east and west, and I'm going to slow down the Earth's revolution around the sun. I'm going to make it orbit slower so we can get a sense, so night after night, if we go and observe at midnight, so relative to this purple line, what direction does it look like the stars are moving in? So as the Earth makes a slow orbit around the sun, you can see that the stars appear like they're moving this direction. So the stars, night after night, are appearing a little bit more towards your western horizon. So from night to night, the stars appear to move westward. How much are they moving westward? And we covered this in the solar day versus the sidereal day. Night to night, the Earth is orbiting about 1 degree. So these stars, every star will appear about 1 degree westward from where it was the previous night, from midnight to midnight, measuring time by solar days. So night after night, the stars appear from midnight to the next midnight. The stars look like they have shifted in the sky by about 1 degree to the west. And I wanted to go ahead and show you another part. So now we know that the stars look like they're moving a little bit westward. I've talked about we have the annual progression. I really just want to hammer in that you can tie all this to seasons, which is going to be a topic of another video. And we could even say that we have, say, our spring skies, our summer skies, our fall skies, our winter skies. So you can have your spring constellations, your summer constellations, your fall constellations, and your winter constellations. So we're just going to watch the same thing we've already seen, but we can see that as the year goes on, what stars you can see are changing. And now you can start associating those, what stars you can see are associated with the seasons. And perhaps you are trying to establish a new civilization, or you're trying to build agriculture for the very first time. And you want to wait until, as you're going from this point from winter into spring, the first time you start to see some constellation that you know, you can only see that, you first start to see it, it rises starts to rise at midnight on this certain day, that marks spring. So maybe you should go start planting your crops. The other thing we need to talk about is where the sun would appear. So if we could turn off the sky, so we didn't have blue skies, we could actually see the stars during the daytime, the sun would just be another star in the sky, and we could see what background stars it's hanging out with. Of course, that's going to change as the year moves, because our perspective, shown by now an orange arrow pointing towards the sun, and this orange circle is going to show us the path of the sun through the sky over the course of the year. So right here, this is where the sun would look like it's hanging out with the other stars, and it's carving out this path as it makes its annual motions through the sky. This path that the sun takes through the stars on the celestial sphere over the course of a year is defined as what we call the ecliptic. So just a good word to know, this orange line represents the ecliptic. And it just tells us it's the path that the sun is taking through the stars as the earth makes its motions around the sun. So this would be marking where the sun is at noon, what stars it's hanging out with. So as the earth is making its journey around the sun, and the sun appears to hang out with different stars, we could ask ourselves, hey, what constellation is the sun in at this time of the year? So we can go ahead and do that. And this is a little bit of a different perspective. So here's the orbit of the Earth revolving around this way. And this is where the sun would look like it's hanging out with. And now we can see what constellations, this sort of orange pinkish line, fall on the ecliptic. What constellations will the sun hang out with over the course of the year? So you could go ahead and chart this, and you would notice that the sun passes through 13 different constellations. This is how astronomers define the astronomical zodiac. Not the astrological zodiac, the astronomical zodiac. It's defined by what constellations fall on the ecliptic, what constellations the sun will pass through, what constellations the sun will be a part of over the course of a year. And there are 13 of these constellations. The weird missing one, oops, hit the wrong button there, is this one right down here, Ophiuchus. So the sun passes through Ophiuchus, I believe, in November-ish. Yeah, so if this is June, over here would be December to November. This is our 13th sign of the zodiac. Why it got removed from the astrological zodiac, I don't know. 12 is a nice divisible number, while 13 is a prime number. Probably has something to do with that, so it's easier to set times and calendars with 12 rather than 13. Or maybe they just don't like snakes, because who likes snakes? And Ophiuchus is the serpent bearer. But yes, there are 13 lines of the zodiac. And we define a constellation as part of the astronomical zodiac if the ecliptic passes through it. The ecliptic is the path that the sun takes through the stars over the course of a year. And the final thing is I want to connect this to our idea of what is observable. We talked about what declinations are observable based on your latitude on Earth. What right ascensions are up at night is determined by the time of year, because we can only observe the stars at night. So this is pretty advanced to actually map this out to know what right ascensions are up given the time of year. So I don't expect you to reproduce that, but you should know that the time of year determines what right ascensions are visible at night. So we define right ascension 0 of where the sun would be at the vernal equinox, so March the sun would look like it's right here in Pisces. So that would be our right ascension 0. And notice that it's in September is when the night side of the Earth would be pointed this way. So in September, due south at midnight, you would have right ascension 0 pretty much on your meridian. And you could see your horizon extends 6 hours this way, 6 hours that way, 12 hours, half of the circle, half of the 24. So at night, you could see from right ascension 18 through 0 all the way to right ascension 6. In December, now the night side is pointed over here. So at midnight on the winter solstice, this point right here, right ascension 6, would be on your meridian at midnight. And you could see 6 hours before, 6 hours after. So you can see all the stars that have right ascension 0 to 12 hours in December. And I could go ahead and do March. Now the night side is pointed right towards 12 hours. So in March, you could observe right ascension 6 to 18. And then go ahead and complete it since I'm already so far. In June, you can observe right ascensions 12 hours to 0 hours. Going through 18. All right, and I want to go ahead and give you a little bit of a stellarium demonstration, just so you can see how this plays out in the night sky from our earthly vantage point. So let me go ahead and switch over to my stellarium view. All right, so you should be able to see my stellarium. First thing I'm going to do is make this full screen so it's easy for me to navigate. So again, I've just set this to be at 10 p.m. And here is our pattern of stars. And what I'm going to do is I'm going to advance time at first by 1 solar day from 10 p.m. to the next 10 p.m. And I want to see what direction the stars move in. So 1 solar day later, oh, the stars shifted and they moved to the west by about 1 degree. 1 degree, 1 degree to the west, 1 degree to the west. And you can see the days 10, September 11th, 12th, 13th, 14th, 15th, 16th. Go ahead and hold the button down so you can see this annual progression. You have different constellations. And for this one, I have turned the sky off so we don't have to worry about the oh, no, the atmosphere was on. Sorry about that. So observing at 10 p.m. over the course of a year. And now we're in May of 2021. All right. So what about the motions of the sun? So for the sun, let's go to roughly local noon, which if I account for daylight savings time, that would be closer to 1 p.m. And let me zoom out a little bit so we can see the sun, a little bit too far. So there's the sun. I have the sky on. You can see the constellations. Let me turn the sky off. So now we can actually see the stars that it's hanging out with. Let me turn on the line for the ecliptic. The sun's right on the ecliptic. And now I'm going to start advancing time, 1 day at a time. And you can see the sun is just moving along the ecliptic and it's starting to hang out with different constellations. Let me turn on the constellation names. So now it's in Leo, and then it'll be in Virgo, making its way through the zodiac, Libra, Scorpius, Ophiuchus, Sagittarius. So there's the sun winding its way over the course of the year along the ecliptic. You might be paying attention to those planets as well. Wait till I get to the video explaining planetary motion, but notice that the planets are all close to the ecliptic as well. And since we're all here, I also would like to just show you one other thing. So for this, it really helps if I draw your attention away from the ecliptic. And let's just take a look at what the sun does if I advance time, keep everything nice and steady. So now I'm advancing time by the sidereal days, so we can see everything nice and smooth. All right, so now you can see what the sun's motion is throughout the course of the year. You can see how the stars are moving a little bit westward over the course of the year. You also have seen that Stellarium is a very powerful tool. I really recommend downloading it and playing around with all the concepts we've been playing with, all the demonstrations I've been doing. You can go ahead and start playing around with it. One quick thing, if you're confused by the controls, this help window down here will show you all the various keyboard shortcuts. All right, so thank you for tuning into this video. I will see you when I talk about the seasons.